Hi, in this video, I am going to discuss about the k-means clustering algorithm. K-means clustering algorithm. So, k-means clustering algorithm is one of the frequently used clustering algorithm. There are different types of clustering algorithms are there. So, one of the best algorithm is k-means clustering algorithm. So, k-means is one of the non-hierarchical clustering method in which the number of clusters is going to be specified in advance. So, that means suppose here the data set contains a number of elements are there. Okay, this is the entire space of the our data set or our space of the data set. Okay, now these are the different samples. Okay, they are the different samples. Okay, and I want to make these samples into different groups. Okay, simply you have to specify the number of groups. So here the number of groups are equal to 3. For example, I want to make the number of clusters are equal to k equal to 3. Okay, so here you have to maintain the two important principles. That the first principle is intra-cluster distance are to be minimized. That means the distance between the one element in the other element that within the cluster must be minimized. So like that, that means all elements in the corresponding cluster are going to be same behavior. Okay, like that we have to identify the number of that intra-cluster distance are to be minimized. That is one condition. The second condition is inter-cluster distance are maximized. That means the distance between the one cluster into other cluster must be maximized. Okay, the elements the distance between the one cluster element into another cluster element must be maximized. Like that we have to make the clusters. So here, based on this data set, I want to make the 3 clusters. So for each cluster, there must be one centroid. Okay, like C1, one centroid in the cluster 1. Okay, center 2 and the centroid 3. Like that, we have to form the centroids. Based on the centroids only, we have to maintain the form the different clusters. Okay, which of the elements are that are very close to centroid 1? Those elements are belonging to one corresponding cluster. Okay, so like that we are going to be form the different clusters. So here the observations in the samples are assigned to one of the clusters like C1, C2, CK based on the distance between the observations and the corresponding center of the centers. Okay, so here in order to form the clusters we have to follow different steps. Okay, we'll see the k-means clustering algorithm here. So the first step is decide the value of k. So decide the value of k. That is very important. So here based on our data set, you have to define the how many clusters you are going to form. So that is, for example, here the number of clusters are to be k equal to 3. Now choosing the k observations from the data that are likely to be in the different clusters. That is very important. Choosing the k observations from the data. We are having the data. Okay, from the data they are going to be in the different clusters. So that is very important here. So there are many ways of choosing these initial k values. Okay, the easiest approach is to choose the observations that are farthest. Okay, so based on that you are going to find out the observations. So now the k observations selected in the step 2 are the centroids of those clusters. For example, here we are having the different this is the data set. Okay, this is the data set. I want to form the 3 clusters. So like 3 clusters. Okay, so here among these observations, all these observations. Okay, suppose this is a cluster 1 k equal to 1 and cluster 2 and cluster 3. There are 3 different types of clusters are there. Okay, so we have to form the initial observations for the clusters 1, cluster 2, cluster 3 like that. Okay, now here for each cluster there must be a centroid is there. Okay, for each cluster there is some centroid is there. For example, some centroid. This is for example, this is the centroid, initial centroid 1. Okay, centroid 1 for the cluster 2. This is the centroid for the cluster 2. Okay, this is the centroid for the cluster 3. Like that we are having the different clusters. Okay, centroids are there. So the k observations selected in the step 2 are the centroid of those clusters. That means based on the our data, we have to select the number centroid for the each and every cluster. So okay, for suppose here we are having the k class, we want to form the k cluster, 3 clusters. So that means each cluster there must be a centroid. Okay, so in the step 2, we are forming the centroids of the, we are forming the centroid of the those clusters. Now for the next step is for the remaining observation. So okay, remaining observation, find the cluster closest to the centroid. Okay, now from the all the observations, from the centroid we have to find out the what are the elements that are very closest to these centroids. Okay, so we have to find out in the step 4. That means for the remaining observations, find the cluster closest to the centroids, and here add the new observations to the cluster with the closest to centroid, and adjust the centroid after adding the new observations to the cluster. Okay, and the closest centroid is the chosen based on upon the appropriate distance measures. Okay, so initially the elements are, for example here the some points are there. Okay, some points are there. Okay, some points are there. Okay, initially you want to form the 2 clusters. For example here, based on the data set, you want to form the 2 clusters. So initially what happened, this is the based on our data set. Okay, this is one cluster, this is one cluster, and this is one cluster. This is the C1. Okay, this is the C2. First of all, we are all from all the data, we have to make one point and become the one observation become a centroid, and here also one point become a one cluster. Okay, one centroid. Okay, this is the C2. So based on this C2, C1 and C2, we have to find out the distance between one element to other element. Okay, one element to other element in the other data set also. Okay, and also we have to find the distance between one element to other element in the other data sets. So based on our 2 principles, that first principle is the intra-cluster distance must be minimized and the inter-cluster distance have to be maximized. Based on this principle, we have to group them into different clusters. Okay, that is the initial step 1. And based on this step, okay, next we are going to add some element to the one cluster, and we are going to remove element to the element from the one cluster. Okay, this is some process going on between the different iterations. Okay, now repeat the step 4 until all the observations are to be assigned to a cluster. Okay, so this process continues until the centroid does not changes the end. Okay, so if you follow this process until all the centroids must be same. Okay, previous centroid and in the next iteration centroid must be same. Like that, this process continues. Simply this algorithm is called as a k-means clustering algorithm. Now we'll see one example here. For example, our data set is income data CSV. Okay, that means here it contains income and age of the corresponding person. Okay, so here it contains 300 rows are there and 2 columns are there. Here there is no class labels. There is no class labels. We have to assign the class label for the our here we are having the income and age, and it contains 300 rows and 2 columns are there. That is the income and age. Okay, our aim is we have to form the 3 clusters. We have to form the 3 clusters. So first of all, you have to visualize the data, so that from that we can understand how many clusters are going to be formed. So based on our visualization of the data, all the 300 rows and 300 column, 300 instances, we can make the 3 clusters. So this is for example, this is a cluster 1. Okay, K1 and K2, and remaining elements are become a cluster 3. Like that, you can form the different clusters. Okay. Now initially what happened? One element become a one. So whatever the element in the corresponding cluster going to be initially one centroid. Okay, this is one centroid, one of the centroid for the cluster K1. For example, this is the centroid for the cluster 2, and this is the, for example, the center for the cluster 3. Like that, we are going to assign the things. Okay, and this is the first iteration. Then we have to find out the distance between the one element to other element. Okay, from with the corresponding centroids. Okay, and then we can adjust based on the principles of the intra cluster distance must be minimized and inter cluster distance must be maximized. Based on the principles, we can adjust the that centroids in the different iterations. Okay. Now from the sklearn, we have there is a library called as a k-means algorithm. There is a k-means library in the sklearn. Okay, k-means algorithm is implemented in the sklearn. Okay, initialize the k-means with the number of clusters as k equal to 3. Our aim is we have to form the number of clusters are to be 3 as an argument. Okay, and then call the fit function for the corresponding k-means algorithm. That means here initially our data set is suppose income data data dot csv. Okay, on this data set we are applying the our algorithm called as we have to define our model is called as a k-means model. For this k-means model, suppose model equal to m1 equal to k-means of the k equal to 3. We want to form the 3 clusters. Okay, and then we are based on our data set, our model, we have to train the model. Okay, train them with the corresponding data set. What the data set here? Income data dot csv. We have to train the model. Okay, now which contains the entities and their features that need to be clustered. And from the sklearn dot cluster import a k-means algorithm, and clusters equal to k-means of 3. I want from we want 3 clusters. K equal to 3 clusters. We want from the 3 clusters, and the clusters dot fit of our data set is equal to clusters underscore df. It contains the our data our income data dot csv. Okay, for this data set we are going to fit our model. Fit is function is to train the model with the help of our input data, that is income data dot csv file. And then so here from the sklearn dot csv, k-means contains different parameters like algorithm equal to auto, copy of x equal to true, init equal to k-means plus max underscore iteration equal to 300, n underscore clusters equal to 3, n underscore int equal to 10, n underscore jobs equal to 1, pre-computer underscore distance equal to auto, random underscore state equal to none, tolerance equal to 0.001, and verbose equal to 0. Like that, we are having the different types of parameters are there. So these are called as hyperparameters. According to your requirement, we can change the number of all these parameters. Okay. So here the default max iterations are number of iterations are to be 300. Okay. The output variable clusters dot underscore clusters dot labels. The output label contains the output variable contains clusters dot labels underscore contains the labels that identify the cluster to in which the observations are belongings. Okay. We can concatenate with cluster customers data, and we can verify the corresponding class label or clusters label. So here customers underscore df of cluster id equal to okay corresponding clusters dot label. This is our output label clusters dot labels that are assigned to cluster id, that are assigned to cluster id. That means we are creating the initially what happened, our data set contains only income and age. Okay, income and age. Now we are going to create one more field that is called as a cluster id. Now that is for this cluster id we have to assign the value as a clusters dot labels. Okay, clusters dot labels. If you display that one clusters dot labels, you will get the all these are the different labels. Okay, these are the different labels like 0, 2, 0, 1, 1, 2 like that. So here 0 nothing but a cluster 0, k equal to k cluster 0, cluster 1 and cluster 2. There are 3 clusters are there. Number of clusters are equal to 3. That means the number of clusters are the names of the corresponding clusters are k0, k1, k2. So the labels are equal to 0 and 1 and 2. There are 3 different clusters are going to be formed for the all the 300 instances. Okay. Now see this one. This is the initial our income and corresponding age of the person. So corresponding if these features are there, then corresponding cluster ID equal to 1. If the income is a high value and age is going to be low value, the corresponding cluster equal to 2. Okay, and for 47,800 and the age is 46, the corresponding cluster equal to 1. So like that, if the income is very high, and age is also somewhat high values, then at that time the cluster equal to 0. So like that we are going to form the different clusters. Okay. Now let us first of all, if we print the first 5 customers with corresponding cluster IDs are, okay, cluster centers are customers underscore df of 0 to 5, 0 to 5. That means all the 5 rows up to first 5 rows. Okay, income and corresponding age and corresponding cluster ID. So these are the different cluster IDs for the first 5 rows. And the 3 segments are numbered as a 0, 1 and 2. The first customer belongs to cluster 1, where the second customer belongs to cluster 2, and so on. Okay, so plotting the customers with their segments. We will plot the and depict the each customer segment with a different marking. So here we are using the different types of symbols to represent the different types of clusters. So for example, here plotting the age and income of the customers from the different segments with different markers. Okay, like the markers are plus and cap and dot will depict the clusters differently. Okay, so here the markers are, we are going to define the markers are plus and cap and delta symbols. Okay, and dot symbol. Now the sn dot im plot age and income, they are the 2 important principal variables. Okay, age and income, and the data set equal to customers underscore df, that is our data frame, and hue equal to cluster ID. Based on the cluster ID, we are going to change the cluster corresponding color, and fit underscore recreation equal to false, and the markers equal to markers, and size equal to 4. If you do this command, okay, we are going to see the different colors here. Okay, so here the cluster 1, that is the one cluster 1 is the, okay, this is the one cluster 1, and see this one, this is the, it's a dot symbol, and green color is a dot symbol. Okay, whereas one more symbol is a plus symbol, and the other symbol is a delta symbol. Okay, so here for each symbol there is a corresponding cluster ID there. Okay, cluster ID equal to 0, 1, 2, like that. Okay, now so these are the different visualization of our clusters with the help of our k-means algorithm. Okay, now this is one cluster, this is one cluster, and this is this is one cluster. Okay, all the elements are belong to one cluster. Okay, and here this is one cluster, this is the one cluster. Okay, see this one here, what happened, the blue color plus symbols is nothing but one cluster. Blue color is symbol nothing but one cluster. Here these elements are belonging to one cluster. Okay, and the green colors points are belonging to one cluster. Okay, that means here the green color points are belonging to one cluster. Okay, and there are, so from based on our data set, we are going to create the 3 clusters. Okay, one is with the green color, and one is yellow color, and okay, dot color and dot symbol, and delta color, delta symbol, triangle, and plus symbol. Okay, so here we see the difference between the, at this location. What happened? These are very close to these data points. Okay, the green colors are very close to blue color points, but these are belonging to one different cluster, and these blue color belonging to another cluster. So we have to rectify those problems by using the normalization technique. So here from the graph we can say that, okay, here the above clusters are mostly segmented based on the income. So here there are age is there and income is there. Based on the income only we are going to be segmented. Okay, so this is because of salary is larger scale. Salary is a larger scale compared to age. So here the salary is between the 0 to 60,000. Whereas coming to age, that value is between the 0 to 60 only. Okay, so the scale of age is between the 0 to 60, while salary ranges from the 0 to 50,000. Okay, now So for example, the difference in the age between the two customers with age 20 and 70 is significant, but the numerical difference is only 50 only. Okay, so the age between the 20 to 70 is 50. Okay, there is a, according to the numerical value, that value is very high, but according to numerical value, that is value is a very small value. Okay. Similarly, the difference in the income between the two customers with income equal to income of 10,000 and income of 11,000 is not significant. The numerical difference is only 1,000 only. Okay. So that the distance will always be determined by the difference in the salary, not in the form of age. So here, based on the income or salary, based on that value only, we are going to form the different clusters. Okay. Hence, before creating the clusters, all features need to be normalized and brought to the normalized scale. So, in order to avoid the confusion between the different values, you have to apply the concept of normalization. Okay, before applying the clustering technique. So, in the next video, I'm going to discuss about the what is the meaning or what is the how you can perform the normalization. Okay, what is the importance of normalization? How can you perform the normalization? Okay. If you have any questions or queries, please leave them in the comment box. In the next video, I will clarify your doubts. Thank you. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.